Okay, so welcome to this segment as we continue with chemical formula. So in my last video, I just told you, I talked about the steps that you need to take. So let's see if we can actually try to apply those steps in writing this, these chemical formulas. Remember, this is actually the foundation that you need to have in order for you to go to, balancing what we are calling as being chemical equation. So it says write the correct chemical formula for each of the following compounds. So they have given us several compounds, and please pay attention so that you can actually get to to benefit them. So what I'm going to do there, sorry, I'll just create a small space there so that maybe we can actually use it and put down the solution. So the first one is magnesium chloride. Now I want to tell you certain things. For example, if you go to group 7 of the periodic table, you are going to find what we call Friedrich Chiluba, born in Africa. So now, of course, I don't mean Friedrich Chiluba. These are elements. This is fluorine. Yeah, so this is fluorine. This is chlorine. This is bromine. That is iodine. And that's aspartame. Now, of course, it's just a way of remembering Friedrich Chiluba, born in Africa. That's what I use. There are elements like what we are calling as being oxygen. There are elements like nitrogen. There are elements like sulfur. You are going to meet these and many others. So now, when fluorine or any of these that I've mentioned and many others, when they react, the name changes. That's what you need to remember. For example, fluorine, the name changes to, it becomes a fluoride after a reaction has taken place. Chlorine, the name changes to a chloride. Bromine, the name will change to bromide. Iodine will change to what we call as being iodo. Iodide, as you are calling it, but iodo, don't worry, we are going to use that, iodo, and so on and so forth. For oxygen, it will change to what we call as being oxide. For nitrogen, it will be nitride. That's what we may call it, nitride. The name changes. Sulfur, we may call it in this case as being maybe sulfide because it has undergone a reaction. So you need to take note of that. These are some of the some concept that you need to remember when it comes to certain elements. So when some of the elements react, their name automatically changes. So now in this case, we have sodium chloride. What are the two elements or radicals that are combining? Well, in this case, they are just elements. One, we do have what we are calling as being sodium. The correct symbol is capital N, small letter A. Chlorine, capital C, and small letter L there. That's what we know. The next thing, you need to attach the valences. What's the valence? Sodium, if you go to your periodic table, is found in group 1, so it has a valence of 1. Chlorine is in group 7. Those in group 7, 8 minus 7 is a 1, so it has a valence of 1. So you can see what we said when you exchange. Of course, it will be Na, there will be a 1, and that chlorine will be a 1. Remember, this is now a couple, sodium chloride, so you don't need to write sodium chloride and you separate them. There shouldn't be a bigger gap. It should be as close as possible because a bond has actually formed. But remember what we said, valences that equal to 1 do not show. So the correct way of writing that is NaCl without showing the ones there. This is the correct formula for sodium chloride. So that is what you need to remember. I hope it's making sense to you and you are actually picking up that. Let's go to what we are calling as being magnesium chloride. Let's go to the B part there. Magnesium chloride, the correct symbol for magnesium, which is an element Mg, and chlorine, you can see magnesium is found in group 2, therefore it has a valence of 2. Chlorine is in group 7, therefore it has a valence of 1. So what do? You exchange or swap the valences. So this is going to be Mg, remember that 1, and Cl and the 2. Remember, valence that equal to 1 do not show, so therefore I'll write the correct one will be magnesium chloride there. So this is the way it is going to be, magnesium chloride. All right, so that's the correct formula for magnesium chloride there. So you need to remember, this is not complicated. Once you know how to write these chemical formulas, I can assure you, you will not have problems when it comes to writing, writing formulas and hence balancing them. Let's move on and look at the C part there. So for the C part there, it actually says aluminium oxide. Aluminium is in group 3. It has got a valence of 3. If you look at your periodic table, oxide, remember what I told you, oxide, it is oxygen that has reacted. So the element, it's an element capital O, their oxygen, that is now become oxide because it has undergone a reaction. Oxygen is simply found in group 6 of the periodic table, and therefore it has a valence of 2. So when you exchange the valences, it is going to be Al, that 2 will come down there, and close as possible, that 3 will get attached to the oxygen. So that is the formula for aluminium oxide. I hope you are enjoying it and it's not complicated. Please, you can actually subscribe to my channel so that you can actually watch more videos concerning this. Let's move on to the D part. It says calcium nitrate. So calcium, please get to know the correct symbols of the elements on the periodic table. It should become your friend. Nitrate, so it's calcium and nitrate. Nitrate, the correct symbol, this is a radical. If you go among the radicals in the video that I taught you, the correct symbol is NO3. So calcium is in group 2, it has a valence of 2. Nitrate has a valence of 1. So now what we need to do is simply to exchange the valences. So this would be Ca. Right away, if you want, you can ignore the 1. But remember what we said, valences that are greater than 1 and you're attaching to the radical. This 2 is attaching to this radical. So what do you need to do? Enclose the radical in brackets. And what do you do next? That's when you attach that 2 there. So this is the calcium nitrate. Remember, there was a 1 here, but of course you ignore it because 1 does not show in our formula. So that is the correct formula for calcium nitrate. I hope you are following me. Let's do some more examples. We try to finish that. The other one that we do have is actually magnesium oxide. That's the E part, magnesium Mg, then oxide, that was oxygen. Remember, that is a valence of 2 and that is a 2. When you exchange the valences, it will be Mg, there will be a 2 there, and that will be a 2 there. Remember, these are even, 2 there, 1, 2 there, 1. So I'll just write that as being magnesium oxide because the ones will not show in my formula. So that's the way it is supposed to be. All right, let's move on to F there so that you are able to see. Again, it says copper 2. Now on the periodic table, if you go to the periodic table, there are those elements in the depression. So you're going to find that there are some elements in a depression. There's those elements that are found in a depression. These elements somewhere here that are found in a depression here. These elements are simply called as being transition. So we call them as being transition elements. Yeah, transition elements. We haven't assigned them any of the valences that we have. If you notice to these transition elements that are right there. So how do you account for the valence of these transition? Because they are not placed in any group whatsoever. So what is going to happen, like this example F there, for some of those transition elements that are there, the valences they'll give you in the formula. For example, it says copper 2, meaning this 2 in Roman numeral is telling you about the valence of copper. That's what we mean. When we say iron 3, it's telling you that the iron has a valence of what? Has a valence of 3. When you say cobalt 2, it is telling you that this cobalt has a valence of 2. So that's what you are going to be finding in your exam or in your question. They'll give you for these transition elements. So copper, the correct symbol, if you go there, it's capital C and small u. Then sulfate is simply capital S, capital O, and a 4 there. That's the correct formula for this radical. Copper 2, meaning it has a valence of 2. Sulfate is a radical that has a valence of 2. Remember what we said? We can right away reduce that. 2 there, 1, 2 there, 1. So therefore, when we exchange, it will just give us copper 2 sulfate. So you can see that in this case. So that's the way it is going to reduce. What about G, iron 3 chloride? Iron, the correct symbol is capital F and small e. Chloride, it is chlorine. Now, since it says iron 3, it means this iron has a valence of 3. We know chlorine has a valence of 1. So when we exchange, it is going to become iron 3 chloride. So that's the way it is. The 3 will get attached to the chlorine there. That's what we do. Let's conclude as we look at our last one, H, cobalt 2. Cobalt is a capital O and a small a lowercase o. Don't write it capital O, capital C, capital O. That is wrong. That would be carbon monoxide. So capital C, capital O. And what's the other? It's chlorine. So it says cobalt 2, meaning the valence of this cobalt is a 2. Chlorine as a 1. So if you exchange that, the formula will be cobalt 2 chloride. So that's the correct formula that you are going to have. So please make sure that you take your time. If you want, you can copy them in your book and try to practice and go through the steps for writing chemical formulas. Watch out later on as we teach you about how to write, in this case, equations, chemical equations in chemistry. Thank you so much for watching. If you love what I do, please, you can subscribe or you can share the videos, with others as well. Thank you.